Tag, Munich. What are we doing here today?
Dr. Bilo, we're going to meet Professor Thomas Auer. Thomas holds the chair of climate engineering, climate design. He's one of the key person at Transolar, a climate engineering company, and he's going to show us a super nice facade.
Come on, guys, shut up. Let's do our job.
Okay,
Perfect, thanks.
let's go.
Gut.
Ja, machen wir so.
Ja, lassen wir so.
First thing we're going to talk about is unitized facades in principle. Second thing we're going to talk about is the typical materials of unitized facades. Yeah. And the third one is the typical one, the openings.
Certainly a good example here.
ADAC, die zweite.
Yes. So Thomas, now we are in front of the building. This is about unitized facades. We need to talk about the layout, how is a unitized facade working and what is its function?
I mean, unitized, first of all, means prefabricated. So it's a prefab facade. It comes in elements, in units. That's why it's called unitized. And then the superstructure is finished, and then it comes and it's lifted by cranes onto the building and fixed to the building.
Okay, so when we look at this facade, each of this square, that's a unit.
Each square is one unit.
Okay, so it's a non-load bearing structure. So it's just bearing its own load, but the main load is taken by the building.
Yeah, we do have a superstructure out of concrete. It's finished. When the superstructure is finished, these units, these facade units come and they get fixed to the slabs.
Okay, what are the typical materials we use for unitized facades?
I mean, very often it's aluminum framing, can also be timber framing, or a combination, can also be steel, but that's very uncommon. So it's a frame out of, let's say, aluminum with an infill. The infill can be everything. Can be an insulating panel, spandrel panel, can be a window, an operable window, whatever you find.
Okay, and how is it connected to the main structure, to the superstructure?
There are brackets, anchors at the facade. I mean, you're the construction guy, you know better.
But I'm interviewing you, you have to answer.
Okay, I'm coming from building physics, but I've seen it. And so they have these anchors connected to the slabs, and then they connect or hang the facade to these anchors. Of course, you get movements, and these are details which need to be solved.
And openings, normally we talk about openings in this case, so windows, doors, whatever. How do we add openings to these unitized facades, to the infill?
You do have this frame, and in this frame there can be openings. Now in this particular case it's a little different because it's a high-rise building, but you can have doors, you can have windows, you can have tilted windows, whatever you want.
Let's talk about this different type of facades. It's a unitized facade, but it's coincidentally also a double facade or a box window, if we are precise in that. How does that work?
Yeah, it has an outer single glazed layer, which is like a storm window, which is protecting because it's a high-rise building. And in Munich, you can get these strong winds coming from the Alps. So it's protecting, first of all, the shading device, the Venetian blind that runs in this cavity, in this box. But also, it helps us to control natural ventilation. Because if you have an open space office, you have two openings on two sides, you get huge cross ventilation.
Okay, and so it protects for wind, it protects the Venetian blind, and it helps you to ventilate. But how does ventilation work in this box windows?
Yeah. So the outer window has a gap, and the air infiltrates into the cavity first by this gap, basically surrounding the outer glass, and then on the inside of the box window, there's a trickle vent.
Guys, may I interrupt? You have a wonderful model over here. Can't you explain it with that model?
Okay, we continue with the model. You're right.
That's a good idea.
So this is one unit, this is one unit, this is one unit. You can detect the unitized facade by, say, seeing these lines showing the units by itself. Okay, that's what we learned. That's one
Exactly.
part. That's one part. Then the second part, the unit comes to the superstructure. So concrete, superstructure, and then the unit superstructure, and then the unit is installed
Attached to
here,
it.
attached
Yeah.
to it. And you said the brackets, so the connection that happens somewhere in here. That also takes the tolerances of the whole movement.
And here you see the Venetian blind.
Okay, how does the box window, the double facade work when you explain it here?
In terms of ventilation, you see here air enters through these gaps. And then you see this little grill on the inside. This is where the air then enters into this cavity. And then from the cavity, you see here a grill. It goes into this trickle vent. And then on this side, it's here, the opening. So this is over the whole height of the building or of the facade. This is the trickle vent, which is controlling the wind pressure. As I said, a high-rise building, you can get extreme wind pressures. So you don't want to open a window to the outside. Yeah, exactly. Can blow people away, basically. Not really, but you want to control it. And so there is a flap inside, which is on springs. If you get more wind pressure, the flap is closing. If you have less wind pressure, it's more open. So it's fairly simple. It's
not electrically controlled, no motors, just a spring to secure it for a long period, no less maintenance.
Yeah, exactly. You also get those, let's say, wind control trickle vents with, let's say, motorized flaps and sensoric, etc., where they measure the pressure difference, etc. But you can also have it fairly simple.
Okay, this is a design choice which is done here.
Yeah.
Okay, good, thanks.
I mean, here you can drop me off.
Oh yeah, that's okay. We do it here. We do it.
Okay.
Okay, Thomas, take care.
Take care.
Bye.
Bye, guys. Enjoy your trip.